the last section in chapter 4 is 4.8, which is going to look at a special type of function called the rational function. It's not a polynomial type. This is when we're going to look at functions where we've got powers that are not whole number values. They're fractional values or negative values, all right? So that's what we're going to look at. That's what rational exponents are. We're going to look at simplify radical and rational notation. We're going to understand properties, graphs, and be able to solve equations involving power and rational functions. Again, complex power and rational functions. So we're going to review. This should be a review of how powers work, and specifically looking at cases where we get either negative powers or fractional powers. All right, so negative powers and fractional powers. So we either get some 2/3 power or negative 2/3 power or negative 2 power. All right, and so we're going to look at those types of cases. The properties are stuff this really should be a review. You should have seen the properties before. All right, so the first one is just reminding you of the properties of power. So these are your power rules, your exponential properties. All right, so the first property that we're going to talk about is really just how to rewrite it. So if I have b raised to the fractional power m divided by n, well, I can take b raised to the fraction part, 1 over n, and then raise that to, it's the exact same thing. B raised to the 1 over n, and then that whole thing raised to the m. And you've got to remember what the fractional power is. The fractional power is a rational function, meaning it's a root. The fractional power 1/2 is the square root function. So the fractional power 1n, 1 over n, is the nth root. And so these can be rewritten as roots. This is the nth root of b, and that whole thing raised to the power m. Right, that's the exact same expression as the one above it. And that's equal to taking the, oh, I wrote those two the same way. This should have been m, and this should have been the fraction 1 over n. All right, so it should be b raised to the m raised to the 1/n. And so b raised to the m, and that whole thing under the nth root. All right, remember, fractional powers are the root parts. And so an example of where that's sort of used, so looking at an example, suppose I have 4 raised to the 3/2. Well, that's exactly the same as 4 raised to the 1/2 cubed, or 4 cubed raised to the 1/2 power. Well, remember what the 1/2 power is. The 1/2 power is the square root function. And so 4 to the 1/2 and then cubed is the same as the square root of 4 cubed, or I can write 4 cubed square root. And again, all of those, if you typed any one of those 5 things in your calculator, all of them should come out 8. Right? I know it's 8 because this is actually the easiest one to look at. If I take the square root of 4, well, I know that's 2. 2 and then cubed will give me 8. But if you plugged any of those into the calculator, they would all give you 8. 4 to the 2/3 power gives you 8. 4 to the 1/2 then raised to the 3rd gives you 8. 4 to the 3rd raised to the 1/2 gives you 8. Square root of 4 cubed gives you 8. 4 cubed under the square root also gives you 8. All of those are equivalent ways to write the same value. Second property, which actually we utilized a little bit in the previous one. So if I've got b raised to the r, remember r is just some real number value, and then raise that to the p, well, that's exactly as taking b raised to the number r times the number p. And so again, an example would be something like 2 raised to the 1/3 and raise that to the 6th. And so I multiply out 2 to the 1/3 times 6, which comes out 2 squared, which I know is 4. All of those are the same. 2 to the 1/3 raised to the 6th is exactly the same as 2 to the 1/3 times 6, which simplifies to 2 squared, which is 4. If you typed any of those in, all of them will give you the equivalent answer, 4. And a lot of times we'll use this to solve expressions. I'm going to do another example. So 4 raised to the 3/2 raised to the 2/3. Right? 4 raised to the 3/2 to the 2/3. Well, it would be 4 raised to the 3/2 times 2/3. And again, the reason why I set up this way, this is often how we'll solve equations, which is what we're going to eventually get to. Those are reciprocals of one another, right? When I multiply them out, I'm left with 1. So that simplifies to 4 to the first, which is just 4. And this is often how this is the way we will use fractional exponents to solve equations a little bit. All right, when we get to solving equations, we'll do that. All right, next example, next rule, property. All right, property 3 has to do with negative powers. So if I have some number raised to a negative degree, remember the negative degree really means reciprocal. So that's the exact same as saying 1 over b raised to the r. And when I move it down and I take the reciprocal, it's no longer a negative power. So if I have 2 to the negative 3, it's exactly the same as 1 divided by 2 cubed, which is 1 over 8. Right, if you take 2 to the negative 3, it's the exact same as 1 over 8. It works in the other way too. If I had 1/2 raised to the 5 to the negative second, so 1 over 5 to the negative second, well, I take the reciprocal, and so that's the same as 5 squared over 1, which is just 5 squared, which is 25. And so the negative power just means take the reciprocal, flip it over the fraction. Alright, next property is going to look a lot like the second one we did, but it is different, property 4. When I have the base b raised to an r, and I take another base b, but raised to the p, alright, so I've got two separate numbers, I've got a number, but they're the same. So b raised to the r times b raised to the p is the same as b raised to the r times p. Alright, so if I've got an example, 3 raised to the 5 halves times 3 raised to the 2/3. Well, that's exactly the same as 3 to the 5 halves times 2/3, and that simplifies 3 raised to the 5/3. Which again, I can leave it like that, or if I wanted to write it as the root, that would be the cube root of 3/5. Alright, the last property is the division property. B raised to the r divided by b raised to the p, where b is the same number and r and p are just real number values. Well, that's exactly the same as b raised to the r minus p, right? I subtract my powers. If it's the same base, now it's just like multiplication, has to be the base. So an example would be, suppose I had 5 to the 4/3 divided by 5 to the 1/3. Well, that would be 5 to the 4/3 minus 1/3, which comes out 5 to the 3 over 3, which is 5 to the first, which is just 5. All right, so again, these properties are all ones that you should have seen before. The only sort of part that we're sort of reviewing with you, all right, so they're all the same properties for exponential functions. The part that we're reviewing is sort of, well, we can do these with fractions or negative values. And we're going to eventually get to solving equations of these types with fractions and negative values. All right, we'll stop there. Pick up the next set of notes, simplifying expressions using these rules in the next set.